Hello, 5th period. I know you miss me. I know you do. I can feel it. First thing we're going to do is go over Math Workshop, which I know all of you have completed by now. So go ahead and have that out so I can go over the answers with you. I'll start with number 1. Square root of 56, a squared, b to the 4th, c to the 5th. Alright. Is 56 a perfect square? No, but perfect square that goes into it is 4 and 14. We don't have to break up a squared because it's even number, same with b to the 4th, but c to the 5th we have to break up into c to the 4th and c. Why? So we can have an even number, and also because 4 and 1 make 5. So square root of 4 is 2, square root of a squared is a, square root of b to the 4th is b squared, square root of c to the 4th is c squared. So all we have left underneath the radical that are not perfect squares are 14 and c. Hopefully everybody got that one. Alright, next one, number 6. Wake up, Cordell. Wake on up. Alright, this one should have been really simple. When we multiply things with the same base, we do what with their exponents? I hope you said add. So that's 6 plus 3 plus 1 is q to the 10th power. Alright, next one, number 9, is 9k squared minus 49. You're supposed to factor by using what? Anybody? I hope you said difference of squares. Why? Because it's difference, plus these are both perfect squares. So make my binomials. Square root of 9 is 3, square root of k squared is k, square root of 49 is 7, but we need a negative 7 and a positive 7 because this 49 is negative. Alright, last one, number 12. There's 4 terms, so you know you're going to have to factor by grouping. So that's what I'm going to do. Alright, this has 4 and an x in common. On the inside would be x plus 5. Here they have a negative 3y in common. Inside would be x plus 5. So final answer, 4x minus 3y and x plus 5. Doesn't matter what order these binomials are in. Like if you had x plus 5 first, then this one, that'll be fine. I hope y'all got most of those correct. Make sure you corrected them if you got them wrong. Now I want you to get out your 5.3 notes. 5.3 is what we're learning today. Should be a pretty easy chapter. Don't forget you got a test this week on 51353. This is the last chapter you'll learn before your test. Alright, first thing we're going to be identifying are polynomials in one variable. Polynomials in one variable. So there's 3 conditions. These conditions are when it's not okay. Like if you see one of these 3 things, it is not a polynomial in one variable. Make sure you write these 3 things down, because if you ask me about them later, I'm going to say, hey, well, let's get out your notes and review what they are. And then if y'all don't see them, I'm going to say, tough luck. Should write it down. Alright. First thing that cannot happen if it's a polynomial in one variable are 2 different variables. Such as if you see an x and a y involved, it is not a polynomial in one variable. Pretty simple because there's 2 variables. It has to be just one. Second condition, you cannot divide by letters. No dividing by letters. So an x and a y cannot be in the denominator. And then the last thing, in order for, the conditions, this is a not condition, is if there's like square roots of letters involved. This cannot happen if it's going to be a polynomial in one variable. So what we're going to do is use these 3 conditions to check if a bunch of these polynomials are a polynomial in one variable. So if you'll move down to guided practice, 1A, 1B, and 1C we're going to do together. Alright, checking the conditions for 1A. Do you see two variables? I only see one x involved. There's no like y, z, or anything else. Do we see any dividing by letters going on? Yes, right here. There's a letter on bottom, means we divided by a letter. So this is not a polynomial in one variable. This one, do you see more than one variable involved? I don't. I just see an x. Do we see any letters on bottom? No. Do we see any square roots of letters? No. So this answer is yes. Now there's two more things I want you to do if it turns out one of them is a polynomial in one variable. We're going to learn what's the degree and how to find it, and leading coefficient. That's what LC stands for, leading coefficient. The degree is dealing with exponents. What's the exponent here? Good, 6. This one's 4. This one's 3. This one's 0. Which one's the biggest one? 6, that's our degree. Whatever the biggest exponent is, that's your degree of a polynomial. Alright, who remembers what a leading coefficient is and can impress Miss Price by telling her? Well, if nobody, hopefully not. Leading coefficient is a number in front of a variable. So the leading coefficient is going to be whatever our highest exponent is, this one, the lead number in front, which is 5. Now I don't care what the actual number is, but is 5 positive or negative? It's positive, that's all I care about. Leading coefficient is positive. Next one, do you see more than one letter? Nope. Do you see any letters on bottom? No. Do you see any square roots of letters? No. So this one passes. This one is a polynomial in one variable. Now write down degree and leading coefficient. What is the highest exponent that you see? Very good, 6. And so this is our leading coefficient, whatever number's in front. I just care if it's positive or negative. This one is negative. Alright, what you're going to do is put away your cell phones, and do 1 through 8 on your own, just like these. Tell me yes or no. If it's yes, tell me the degree and leading coefficient. Go ahead and do 1 through 8 on your own. Miss Price is going to pause the video, and then when you guys get done, just put your pencil down. That way she can know when to unpause it. She can check your answers. Alright, first one is yes. It is a polynomial in one variable. Degree, I'm just going to put D for that, is 6. Leading coefficient is positive. There's our degree and leading coefficient. Number 2, this is a polynomial in one variable. The degree is 7. Leading coefficient is negative. There's our degree and leading coefficient. Next one, this one's no. And if you see why, it's because it has an x and a y. It can only have one variable, not two. So this one's not a polynomial in one variable. Same thing here. We got an x and a y, so it is not a polynomial in one variable. What about number 5? Yes or no? No, because of the x and the y. What about number 6? No, because you're dividing by a letter. Number 7, yes. Degree is 6. Leading coefficient is negative, right there. Number 9 is yes. Leading coefficient is 7. Degree is 7. Leading coefficient is negative. So everybody, hopefully, y'all have a good idea of finding the degree and leading coefficient for polynomials. If you have questions, write them down so I can address them tomorrow. Alright, flip it over. Next thing we're going to look at is evaluating polynomials. We won't spend a lot of time on this because we've done this before in this class, but first thing we're going to find is W5 for this function. Now what's the difference between Wx and W5? All that's the difference is they replaced x with 5 right here. See how they replaced x with 5? That's what we're going to do in this function. So we're going to rewrite this, except everywhere there's an x, I'm going to put a parentheses. So I'm going to have -2 parentheses cubed. See how I didn't write the x, I just wrote parentheses? Plus 3 times parentheses minus 12. And I'm going to plug in, instead of x, a 5 everywhere an x was, which are these parentheses spots. From here, it's just doing order of operations. So what comes first in order of operations? Parentheses. But as you can see, there's nothing to do inside these parentheses. So we move to exponents. A lot of people make this mistake, so please pay attention, guys. Here, do not do -2 times 5, which is -10, then cube it. The only thing that's being cubed right now is 5. So you'll do 5 cubed, which is 125, plus 3 times 5, which is 15. Now we need to multiply here, so -2 times 125, which is -250, plus 15 minus 12. So now we do -250 plus 15. That's -235, and then minus 12, -247. So when you're evaluating a function, you should get one number for your answer. No letters involved. Next one we're going to do is find w of -4 for this function. So I'm going to take every x and put parentheses instead of x's right here. So 2 parentheses to the 4th minus 5 parentheses to the 3rd plus 3 parentheses squared minus 2 parentheses plus 8. And then each parentheses I'm going to put in a -4. Alright, first thing, again, inside the parentheses there's nothing to do, so move to exponents. So -4 to the 4th power, I want you to type that in your calculator so you can make sure that you're getting the right answer. Make sure that you're typing it in, parentheses -4, then raised to, that's this button, to the 4th. Okay? Should be getting positive 256. If you're getting negative 256, it's because you didn't put this in parentheses. So 2 times 256 minus 5 times, go ahead and find -4 to the 3rd power. This time you should get a negative number. It should be -64 plus 3 times, we know -4 squared is 16. And then we can go ahead and multiply this. That would make a positive 8. And we have this plus 8 also right here. Alright, start by multiplying. So 2 times 256, it's going to be 512. -5 times -64, that's going to give you a positive 320. 3 times 16, it's going to be 48. And 8 plus 8 is 16. And now we just add all of these together. Go ahead and do that on your own. Should have gotten 896. Alright, what I want you to do is just find, and circle this so you'll remember, P of 3. We're not going to do all of these, just find P of 3 for number 23 and 24. P of 3 for number 23 and 24. And Ms. Price is going to pause the video so you can try these on your own. Once she unpauses it, once y'all are done, you can check your answer. Alright, P of 3 for number 23 is 66. If you did not get this or you have a question, put a question mark so we can go over this tomorrow, okay? For number 24, let's see. This one you should have gotten negative 93. Again, if you did not get this, just write a question so that way we can go over it when we get back, or when I get back tomorrow. Alright, now I want you to look at these two polynomials, okay? This is in standard form. How do you know when something's in standard form? Write this underneath. Y is solved for. Y is solved for. Plus no parentheses. That's how you know if it's in standard form. Y is solved for, also no parentheses. This is when a polynomial is in standard form. When a polynomial is in factored form, you can see that it has parentheses. So what we're going to work on is finding the zeros of a polynomial. That's what it says here, find the zeros. What are zeros? Those are our x-intercepts. And what are x-intercepts? That's when your graph or polynomial crosses the x-axis. So what we're going to be doing today is finding the zeros of polynomials. When it's in factored form, and let me see if you can tell which are in factored form, that's going to be all three of these because they have parentheses. When they're in factored form, it's easy. So to find the zeros in factored form, you just set each factor equal to 0. So x plus 1 equal to 0, x minus 1 equal to 0, and x minus 3 equal to 0. And then you just solve for x for each one. So this one I would subtract 1 from both sides, and x equals negative 1. This one I would add 1 to both sides, x equals 1. This one I would add 3 to both sides, x equals 3. Those are the zeros of this polynomial, negative 1, 1, and 3. So quicker way than to set all these equal to 0, you just take the opposite signs. This one, your 0 would be negative 1 because it's the opposite of this. This one it's positive 1 because it's the opposite of this. This one it's positive 3, opposite of that. So on this one, x would equal negative 2. This one, x would equal 3. Those are the zeros. This one's a little different because it has this little x by itself in front. Nothing's changed, just like we found the zeros over here. If you can't figure it out, you just set it equal to 0. So we got x equals 0. That's one of them. This one, x equals, opposite of this is positive 3. This one, x equals, opposite of this is negative 1. We are not going to worry about this until the next chapter, so you can mark out that. Go ahead and flip it over. I want you to do number 4 and number 5 on your own. All I want you to do is just find the zeros. Find the zeros, what we just did. So Ms. Price, if you'll go ahead and pause it while they work on those, and then you can unpause it when they're done. Alright, this one, your 0 is x equals negative 8. So as you can see, the exponent does not change it when it's on the outside. You still just set this equal to 0 and solve. Subtract it, and x would still equal negative 8. This one, if I set this equal to 0, x to the 4th equals 0, and I solve, you could take the 4th root of both sides if you wanted to, but if you just realize that the only thing you can raise to a power to get 0 is 0. This one, x equals 2. This one, x equals negative 7. Alright, Number 6 and number 7, why are they different than 4 and 5? Because these are in not factored form but standard form. These are both in standard. So how do you find the zeros of something that's in standard form? You have to factor. You have to. Which is why we've been doing it so much in math workshops. Looking at number 6, think about how could I factor this one? How could I factor this one? They all have what in common? Good, they all have an x in common. Take it out. So if I took out an x out of all of these, x cubed divided by x, that would be x squared. Negative 10x squared divided by x, negative 10. 25x divided by x, 25. Oops, I forgot an x right here. Now we're just going to leave this x alone and factor this. We know this is AC easy. How do I know? Because there's a 1 here. There's 3 terms. So I just find factors of 25 that add to be negative 10. Think about that for a minute. It's going to be negative 5, x minus 5, and x minus 5. Now you can see that this is in factored form, just like the ones we did here. So all that's left to do to find the zeros is set this equal to 0. So we got x equals 0. Set this equal to 0. We got x equals 5. Set this equal to 0. X equals 5. Last one. If you look at how we're going to factor this one, we notice they have what in common? X squared. They have x squared all in common. So x to the 4th divided by x squared, it's going to be x squared. 6x cubed divided by x squared, just be 6x. 8x squared divided by x squared, just 8. Bring down my x squared. And now we have to factor this, and it's going to be AC easy, just like last time. So what are factors of 8 that add to be 6? Good, 4 and 2. So now go ahead and solve for these. Find your zeros. This one's going to be x equals 0, x equals negative 4, x equals negative 2. And that's pretty much it for Chapter 3. The rest of these notes we're going to get to when I come back. But let me just review what we've learned today, because you're about to do an assignment on your own. Don't forget the conditions. That tells you whether it's polynomial in one variable or not. Don't forget your degree is your highest exponent. Your leading coefficient is the number that's in front with the highest exponent. It's positive or negative. We learned how to evaluate functions, just plugging in a number for all the x's. We learned how to find the zeros in standard and factored form. So that's what you'll be practicing today. So Ms. Price has an assignment, 5-3 classwork. It says classwork homework, but you should be able to do it in class. I'm going to check that for a grade tomorrow. No excuses. So if you need help with it, come see me 0 period, and we're going to go over the answers in class tomorrow, okay? Hope y'all have a good afternoon.